Hello, welcome to Science Chomp. Today we're going to be looking at isotopes. Now, quite simply, an isotope is an atom of an element with different numbers of neutrons. So let's have a look at this example. I've just taken hydrogen from the periodic table. We've got two numbers. You've got a proton number and a mass number. Okay, so if you were to draw it out, you'd have a proton in the middle like so, and circling it, you would have an electron. There's no neutrons here. You've got one proton, which is this, and the mass number refers to how many subatomic particles you have in the nucleus, and in this case it's just one proton in the middle. This has one proton, as I said before, 0 neutrons, and you always have the same number of protons and electrons, so you can write one electron, like so. However, you can also have an isotope of hydrogen with one more neutron. So this is still 1 because this number refers to the proton number. So it's still going to have the one proton here. But along with this, it's going to have another subatomic particle. And in this case, it's going to be a neutron. And the electron is going to be here. It's very badly drawn, but you get the idea. Now, because you've got two subatomic particles in the nucleus, you have a different mass number. So here we've got one proton, one neutron, and one electron. So I thought I'd show this website, share this website with you. I think it's brilliant. So it shows you the different, a few different elements over here from the periodic table. It gives you the numbers of protons, neutrons, and electrons, and this is hydrogen, the example which I showed you. Now here, you've only got one proton with no neutrons, which is why this one's blank, and this shows you the mass number. Obviously, just one, you have one. Now this is an isotope of hydrogen like this, like so, and you can see you've got two subatomic particles in the nucleus, or two nucleons, which we could call that. So the mass number increases to 2, and you've got one proton, one neutron, and one electron. So simply that is what an isotope is. Let's get rid of that and let's pick a different element. So we've got lithium here. Now here we've got 1, 2, 3 protons, and we've got 1, 2, 3, 4 neutrons. 1, 2, 3, 4. If you count all of that up, you should have 7, which is this number down here, and that's the mass number. Bear in mind, you always have the same number of electrons and protons in whatever isotope that you have. So an isotope of lithium would be lithium-8, for example, but this is unstable. So you can even go the other way. You can remove neutrons, and this is also an isotope of lithium. So the only difference between standard lithium, like you see here, and an isotope of lithium is that the neutron number is changed. So have a look at that. Got one more neutron here, now one less neutron. You can pick another one. So you've got fluorine 19. I'm not going to count every single one of those, but you can see them all up here. You can have one extra neutron, which makes it unstable, or you can remove a neutron or remove a couple of neutrons, and these are also unstable. This is interesting, isn't it? So you do get isotopes, and they differ in stability. Let's pick neon. So neon is quite stable as it is. Let's see if we can add another neutron. You can. Can you add 2 more? You can. Can you add 3 more? It becomes unstable. But the idea is this. All an isotope is members, atoms of the same element with different numbers of neutrons. Okay, let's get back to the video. One last thing which I'll add is make sure whenever you're doing isotopes that the protons, they never change. The protons is what gives the identity of the element. So let's have a look at a couple of these questions. First of all, let's look at this question over here. And it tells us that there's 3 isotopes of this element. That element is C, which is carbon. So A, the element is carbon. The number 6, now the number 6 is constant throughout all of those. The number 6 is the number of protons, or the atomic number, you can call it. 12, 13, and 14, that's the larger number. That refers to the mass. How many protons and neutrons are in the first isotope? So if you have a look, the first isotope is like this. I'll write it big so you can have a look. You got 12 and 6, and that's carbon. That's the first isotope. Then we've got 13 and 6, carbon. And we've got 14 and 6, which is carbon. Okay? So what we're talking about here, how many protons and neutrons in the first isotope, that's the protons. And the neutrons is going to be 12 minus 6, which equals 6 neutrons. Now you can do the same for all of these ones. That's the protons. Okay? And for the neutrons, 13 minus 6, which, how much is going to be 13 minus 6? It's going to be 7 neutrons. And for this one, you got 6 protons, same as all of the others, 6 electrons as well. And then for the neutrons, it's going to be 14 minus 6, which is going to be 8 neutrons. Also, bear in mind, there's going to be 6 electrons as well. That's easy. Now, for the next one, looks a little bit, trickier. I've made it bigger like so. The first thing that we've got to do is look up all of these in the periodic table and find the atomic number. So let's try that. Okay, so here we are. Here's the periodic table. The first one I need to find is potassium 37. So let's have a look. Potassium, here we are. And it tells us the atomic number is 19. So you can just write that in a second. The next one was oxygen. Where's oxygen? Oxygen's over here. Now the number that we're after is this number here, the smaller number. What we're going to do when we're looking at isotopes, we're going to ignore the mass number here, which is given as a decimal. We're going to ignore that. And we're just going to take the small number up here. The next one is uranium. Let's try and find uranium. It's down here. Uranium. And again, we're going to take the smaller number, not the bigger number. So the bigger number we can ignore. We're going to take the smaller number, which is 92. And then finally, we've got boron, which is up here. And again, we can ignore the big number, we take the small number, that is the atomic number. So let's fill those parts into our sheet. So the atomic number for potassium, K is potassium, is 19. For oxygen, it was 8. Oh, that's not very good. There we are. That's 19. There we are. That was 8. Uranium is 92, and it's going to be the same for both isotopes. And for boron, it was 5. Again, same for both isotopes. Now, the first thing that you must know is the number of protons is the atomic number. That's why we sometimes call it the proton number. So make sure these are the same. The next thing that we have to know is that the number of protons and the number of electrons are also exactly the same. This is because atoms are what we call electrically neutral. So this is going to be 19, this is going to be 8, 92, 92, 5, and 5. Okay, now the next thing, what we've got to do is we've got to work out the neutrons, but let's put the mass in actually, because that's easy. The mass is this thing. So whenever you get given an isotope, they give you the name and they put a dash and a 37. This is not a minus number, this is just a dash, and it tells you that the mass is 37. The mass of oxygen here is 17. The mass is 235. The mass is 238. The mass is 10. And the mass is 11. So in isotopes, the mass number does change, and we're going to put those numbers over here, dead easy. Okay? The next thing that we've got to do is work out the number of neutrons. And what we do is we take the mass number and we minus the number of protons. So 37 minus 19. My maths is so poor I have to use a calculator, but you know, in an exam, you're going to have to do this yourself. So 37 minus 19 is 18. The next one is 17 minus 8, which is 9. 235 minus 92 is 143. 238 minus 92 is 146. 10 minus 5 is 5. And 11 minus 5 is 6. Yes, I'm using a calculator. Sue me. Anyway, there we are. It's nice and easy. So this is what you've got to do when you're working out isotopes. Thank you very much for watching. I'll see you in the next video.